So what you might want to do is actually just go back to the page that we started yesterday, okay, with the law of cosines. All right, we'll just kind of like run through this again real quick to kind of see it. Okay, refresh our memories a little bit. Okay, so again, law of cosines, right? You can think of it as a variation, or it's just like a corrected Pythagorean theorem, right? There's the c squared equals a squared plus b squared, but then because we're not talking about a right triangle, we need some sort of like correction to fix it so that we, because you know this only is true for a right triangle, but then we add that minus 2ab cosine c to help us then, you know, fix it for any kind of triangle, including right. It would also work for a right triangle as well. All right, and the same thing is true for these other kind of iterations of that same formula. Okay. So just to kind of help you like see, you know, remember this formula, the side c squared here, and then the cosine is of the angle c, right? And then here again, side a squared, and then it's cosine of angle a, and then b squared, and then cosine of angle b, okay? And then within this right here, it's just the other two sides, a squared plus b squared minus 2ab, and then cosine c. And then if it's a, then it's the b and the c, minus 2bc cosine a, and then if it's b squared here, then it's a squared plus c squared, the other two sides squared, minus the 2ac cosine b. Okay, so it's not too bad. They're just, you know, slight variations of one another, just kind of shuffling around the sides and stuff like that. Okay, we did an example here. Well, all I asked you to do was to solve for side a. Okay, so this was a side angle side situation, right? We had a side, angle, and then a side, so the angle is between the two sides there. Okay. Can't use law of sines, right? Because anytime we do a law of sine problem, we need to start with an angle and opposite side pairing, which, you know, is not, you know, given to us. We don't have enough information to do that, so we have to use something else. That's why we need law of cosine. And we can't just use any of those three law of cosine formulas because not all three of them work, right? So for example, I kind of randomly chose yesterday to use the c squared version, and when I plugged those numbers in, I ended up with a, but then I also didn't know what cosine c was, okay? So I had two unknowns in my equation. So I wanted to use the equation that resulted in just one unknown value, which was the a squared version, okay? The a squared version. And basically the idea is this: if you're trying to solve for a particular side, so in this case we're trying to solve for this opposite side here, okay, you want to pick the formula that's got that side as its like starting point. So in this case we wanted a, so we would use the a squared formula. If we were trying to solve for side b, we use the b squared formula. If you're trying to solve for side c, you use the c squared formula to help you with that. Okay. But either way, you just kind of plug everything in, all your information, and then solve for a. You get a is about 35.228. So, okay. And now at this point, what can we do to solve this triangle? What can we do? If we wanted to continue to solve this triangle, what can we now do or use to solve for angle C or angle B there? What can we do? Yes, Spencer? Use sine 45 over 35.228. Exactly. You use law of sines at this point. So use law of sines. Oops. To finish solving the triangle. One bonus is that you don't need to worry about using the ambiguous case here. You don't need to worry about like checking to see if there's more than one triangle here. There's only going to be one. Why is that? Because we started with information. We started with a side, angle, and a side, okay, which means then that this is guaranteed to be one unique triangle. So there won't be two, there won't be none, there'll be one unique triangle here. So, you know, I'll show you the setup here, but we don't actually need to solve it, I guess, because I think we're all familiar enough with law of sines at this point, but... And we'll just solve for, I don't know, sine of c over 19. Okay? So we just cross multiply and solve there. Okay. And I think you would get, let's see here if I can do this real quick. Second sine 19 sine 45 over 35.228. So I get about like 22.4 there for angle C. or sorry, 22.419, I guess I'll say, degrees. And of course, once you have that angle C is 22.419, then you can find B by just doing 180 minus the 45 minus the 22.419. So, okay, like that. And so when we do that, we get about 112.581. Okay, and you can kind of see here again that these answers make sense in like the inequality sense. So what I mean is like between our three angles here, C is the smallest, right? And so opposite that is the smallest side. 19 is the smallest side, right? Smallest angle is C, smallest side is also C. Okay. The biggest angle is angle B, right here, which is 112.581, very much not drawn to scale. And then the biggest side is 46, so that makes sense. And then the middle sized angle is 45, and the middle sized side is the 35.228. So it all fits and it works. Okay. So that's an example of using law of cosines with a side angle side situation. But if you remember, I also told you guys that it works for side side side. So let's look at an example of that. Okay. So you can just see that in action. Because there is something we want to be on our toes about with this situation. Yeah, here we go. Okay. So, again, I'll just say the directions are solve the triangle. Okay, and I'll just draw a picture here. And let's say that side C is 4, side A is 7, and side B is 10. Okay, so essentially here we just have to find the missing angles. That's all. Find the missing angles. Okay. In this situation, again, it's side, 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 right? So we're guaranteed a unique triangle here. There's no need to worry about, other angle measures and stuff like that. But we do want to be careful of one thing, and this is crucial here. We want to start with the longest side. Okay? Or in other words, find the biggest angle first. We always know the biggest angle is opposite the biggest side. Okay? So in other words, we want to find angle B in this case. In this case, that's angle B. Alright? So if we go back to our law of cosine, that's not the right thing. Where did I put it? Oh, here it is. Okay. If we go back to our law of cosines formulas here, and we're trying to find angle B, which one of these three formulas do we want to use to find angle B? Only one of them will get us that. Which one is it? Which one of those three will get us angle we'll be able to use to solve for angle B? The B squared one, exactly right, because it's got angle B in it. Okay, angle A here, angle C here, so we want to use the B squared one. Is that what you're going to say too, Cassie? B squared, okay? Very good. So, I'll go ahead and write it out here. B squared equals, and again, so how do I remember the formula? So B squared equals, and then the other two will be A squared plus C squared minus 2AC, because it's just the other two again, and then cosine angle B, and that's how you remember the formula. Now we just plug in our information here. So it'll be 10 squared, 4 squared, 7 squared. Oops, I did that backwards, but oh well, it won't matter. Cosine of B. This should really be 7 squared plus 4 squared there, I guess. Maybe I'll fix it. Okay, 7 squared plus 4 squared. There you go. So we get 100 equals 49 plus 16 minus, let's see, 2 times 7 is 14 times 4 is 56. please be very careful here about how you solve this. Okay, there's a tendency for students. Okay, there's a tendency for students here to make a mistake in their simplification, and that mistake is normally, one way I see it is though I will see students add these two numbers and then subtract 56 here. So they'll do 49 plus 16 and then minus 56. Okay, but the thing is, you can add the 49 and the 16, but you can't subtract 56 because 56 is being multiplied with cosine b, right? You can't do that. Just like if I had, 3 plus 2x, right, that does not equal 5x, right? They're not like terms. Same thing here. The 49 and 16, they can go together. They're numbers. But it's minus 56 times cosine b. So be careful about how you solve this here. It's often I see students make that mistake, and then they really mess up their triangles from that point. So anyway, so you get 65 minus the 56 there, cosine b. Okay, so we're going to subtract the 65 from both sides first. All right, I'm going to really spell it out here, which gives us 35 equals negative 56 cosine b, and then divide both sides by that negative 56. Okay, and we get negative 5/8 actually cosine b. And so we finally then do cosine inverse of that, and we get angle B is approximately 128.682 degrees. Okay. And then good news, at this point, what can we now do? To solve for the rest of those angles, what can we do? What can we use here? Law of sines, exactly right. Yep, law of sines after this point, because now we have an angle and an angle and opposite side pair to then set up for the rest of our law of sines, and we don't need to worry about the ambiguous case. Okay, but you really do need to start with that longest side. If you don't start the longest side, then you may run into some issues. Okay, so with your trigonometry and stuff like that. So please make sure you start with that longest side. In other words, find the biggest angle first, okay, and then you can proceed from there. Okay. So again, it doesn't matter which one you pick. I'm just going to maybe find angle A here, so we could just say, sine of A over 7 equals, and then sine of 128.682 over 10, and again, just cross multiply and solve for angle A there. Let's see here, and again, I'll just kind of skip through that, and we'll just do this calculation here real quick. So 7 sine divided by 10, so approximately 33.123 degrees. And of course, we can then find angle C by subtracting from 180. And we get about 18.195 degrees. Okay, for angle C then. Which again, makes sense. Angle B is 128, it's opposite the biggest side. Angle C is the smallest angle, it's opposite the smallest side. And angle A is the middle angle, and it's opposite the middle side. Okay. So that's that. Questions on any of that? Alright, so let me give you all one to try here. Let me see. Okay, and I'll just give you one. Okay, let's say so we're going to solve the triangle given that A is 8, B is 19, and C is 14. Okay, solve the triangle given that A is 8, B is 19, C is 14. don't make mistakes.
Oh yes, I did type in something wrong. Yes.
Yes, exactly right. Of that fraction, exactly right. Very good. Well, so when you're finishing up, I'm going to pass out a free response question that we're going to go over together. Feel free to read through it, and if you're done and you want to try starting on it, that's fine too. Whether this one also makes sense within the triangle. So if you were to draw a picture of this triangle and label things appropriately, right? What you see is that angle A is opposite this, right? So 60 degrees is opposite side 4. 64, which is bigger than 60, right? Implies then that B should be bigger than A, and it is, right? Angle B is opposite this one, so this is bigger, this should be bigger than it is. That one works. Likewise, though, this angle, B, right, is also bigger than 60 degrees, and it also implies the same thing, that this side should be bigger than it. So that's why both of those potentially work there. Okay, that's how you can tell. On the other hand, if you go back to the previous page where there's one triangle, right, that's the two solution case. Sorry. So then here for this one, the one solution case, if you consider both of these, this one does not make sense because part of the 8, if I put a 108 here, that's opposite side of 12, but then, yeah, A is equal to 22, so this should be bigger than 2, but it's not. Okay, so that's it. Yes. Okay. So wait, so one of these, so be careful, I think you have two names if you want to, okay. So you want to get B by itself, with the B that you want to get rid of. You want to get B by itself. How do you cancel out a cosine of BA? What do you use to cancel out a cosine? What's the opposite of cosine? Inverse of cosine. Not in cosine is a negative 1. It's just the cosine inverse, right? Or arc cosine. That's good. So, 19. Where's the 36? Right, which you can't do because these numbers you can combine together because they're just numbers. But here it's minus and it says times cosine B. So you can't put this all together. You put these together and equally minus, and then what
whatever 2 times 8 is 14.
I do.
You see what I'm saying? It's a two-step solve you have to do. You can't just do it. I think so, yes. I think I have a slightly different decimal for those two, but otherwise I think it's good. She corrected the switch.
Usually it's fine, but like yesterday I was like, ooh.
Additional quotes. Alright, I already got you. You don't want to do 2? Alright, everyone else has got one of these free response questions? Yes?
Okay. All right, so let's take a look here at this, see how we did. All right, there are your angles. Okay. Again, I'll run you through the steps here because this is, again, just for whatever reason, it's tempting for us to do this. When you go to simplify, and it only really happens when you're solving for the angle. If you're using law of cosines to solve for a side, I don't see this happen so much because you can kind of put it all together when you're solving for the side. But when you're solving for a missing angle, you have to do it in steps. I would really, take your time when you're solving for an angle here. The 8 squared and the 14 squared, they can go together to get 260. The 2 times 8 times 14 gives you minus 224. But these two cannot go together. You can't do 260 minus 224. Okay, here, because it's got that cosine b attached to it. So instead you got to subtract 260 from both sides and end up with this. Okay, right, the negative 224 cosine b just comes down, and we have 101 there now. Then divide both sides by negative 224, so we get this fraction. And equal cosine b, and then do cosine inverse, and you get 116.801. There shouldn't be a case using law of cosines where you end up with an impossible situation, okay? So it shouldn't ever give you an error when you're doing inverse cosine on both sides. That you should, get this. This should guarantee a triangle. And so then we use law of sines. I did to find angle C, which is 41.124, and then angle A is that's supposed to be at 22.075 degrees, okay? And so there's the rest of your triangle. Okay, questions on any of that? All right, we're going to go through this free response question here then and see how we can do with this. Because for whatever reason, bearings can be a little confusing, which is funny because they're supposed to be able to help you navigate, but they're actually hard to navigate. But anyway, so there they are. All right. This is taken directly from a practice free response question for our benchmark. So, in other words, it's like the official county benchmark practice, which means there's a very good chance you'll see a question like this on your benchmark, right? They don't write these arbitrarily. They write them in such a way that they help you to very closely see what will be on the benchmark. So since this is in the practice, there's a very good chance it'll be on the actual benchmark as well. Okay? So just heads up on that. That's why we wanted to practice this. Okay, so, and you may use a calculator. Number 2, a fishing boat heading due south is about to turn towards one of 2 docks. Dock 1 is located at a bearing of south 55 degrees west of the boat. Dock 2, which is 10 kilometers due east of Dock 1, has a bearing of south 32 degrees east of the boat. Round out calculations to 3 decimal places. 7 points. Okay, so letter A, draw a diagram for the situation. Be sure to include all information provided. Okay, so our point of reference here, right, the thing doing the observing, right, both of our bearings are from that boat. So let's go ahead and establish where that boat's going to be. So we'll put the little boat right there. Okay, there's our little boat. Okay, and it's heading south. Okay, so it's kind of, that's why I put it up here, because it's heading this kind of direction here. It's about to turn towards a dock, one of these 2 docks over here. Okay, so if this is like the southward path, all right, because you can never eat shredded wheat or however you want to remember it. Okay, never eat soggy waffles. I don't know, however you remember your compass rose there. Right, south is down. Okay, for us here, and so we've got our southern direction here. Dock 1, okay, is located at a bearing south, but 55 degrees west. Okay, so south, and we go 55 degrees west from that south. Okay, so that means we're going to go out in a westerly direction. That's to the left. Okay, again, if you need your, your compass, however you remember your directions there, right? North, east, south, west. We're just going to use our paper and orient ourselves this way. Okay, so it's going to go south. It's traveling south, 55 degrees west, or traveling the sighted line, I guess. Okay, and so that's a 55-degree angle right there from the boat. 55 degrees. Okay, and then that's at some point along that is dock 1. So I don't want to try and draw a dock, so I'm going to be very boring here and say dock 1. Okay, so it's 55 degrees right there. And actually, that's yucky, so I'll just do it. There we go. Okay, and then dock 2, which is 10 kilometers due east of dock 1. So again, we travel east. That's just straight horizontal direction to the right here. 10 kilometers distance here. And we'll say here's dock 2 then. Okay, it has a bearing south 32 degrees east of the boat. So instead of going to the left for the west, right, we're going to go east. We're going to go to the right here, 32 degrees. So, I don't know, something like this. Okay. Right. And so there's our diagram, right? We've taken care of all the information. Dock 1 is located at a bearing south, 55 degrees west of the boat. So south and then 55 degrees west. There's that from the boat there. So there's that 55 degrees. Okay. Dock 1 over here. And then dock 2, which is 10 kilometers due east. So you just go straight east from that dock 1. 10 kilometers. Has a bearing of south 32 degrees east. So there's our information, right? So letter B then says, which dock is the boat closer to? How much closer is the boat to this dock than to the further dock? Okay. Well, this is kind of tricky. We don't have, it doesn't tell us use law of cosines. It doesn't say use law of sines. It doesn't say use trigonometry. It just asks this question: which dock is the boat closer to? How much closer is the boat to this dock than to the further dock? Okay. So it doesn't tell us what to do here. We want to find this distance right here, right, and this distance right here. Okay, in fact, maybe I can just call this one, we'll call this distance like a distance of x, and we'll call this one a distance y. Maybe I shouldn't use question marks, right? That's not very mathematical. We'll use like x and y. We want to find those two distances. So is there anything we can do here? What can we maybe do to, what's something we can maybe figure out or we can say is true about this triangle? Anything else we can maybe talk about here? Or like get to help us? What else might be helpful here? Any ideas? Any other pieces of this, a big triangle, or kind of, we technically have two smaller triangles here, right? We have this one, and we also have this one as well. So any other pieces that we could like calculate here or say would be, yeah, Melissa?
Like the south line,
With the east.
add like the 90 and the 32, whichever side you're doing, and then subtract it from the 80 and then have like the angle stuff to it.
Yeah, and same thing with dock 1 then, right? Because they're both going to be right triangles. Excellent, exactly right. So yeah, let's do that. 180 minus 90 minus 32. We now know that dock 2, the angle with that due east or due west line, depending on which orientation you're talking about here, that's going to be a 58-degree angle there. Okay. Likewise, the 180 minus this 90-degree angle here minus the 55-degree angle, that yields 35 degrees right there. Okay. So that's helpful. That's helpful because now we have we can look at this big triangle, and we have these two angles, and we technically know the big angle here as well, right? It's going to be 55 plus 32. So the full angle here, if we go like the whole way, and this might be getting kind of busy here now, but that's okay. It's going to be, what, 87 degrees is that big angle, that full angle right there. Okay. And so now how might we be able to find those distances? What can we use here? What can we use? Law of sines, that's right. Okay, so what would our setup be if we're going to use the law of sines here? Sine of what? 87? Yeah. Okay, we know this full angle here, it's 87, and the full side here is 10. So it's the full side of this triangle is 10, and that matches to the full angle 87, right? We want to use the 55. 55 is opposite this piece, which we don't know that distance, right? Or the 32 is opposite this piece in the smaller triangle. Again, we don't know that, but if we say the big angle there, that's opposite 10, so there's our setup for that. And now I can just kind of pick whichever one we want to solve. So let's say we want to solve for x first. So we'll say sine 58 over y, okay, which means that y is equal to 10 sine of 58 degrees over sine of 87. And then we can do the same thing for the other one. Sine of 87 degrees over 10 equals sine 35 over x. Again, cross, multiply, and solve. Sine 35 over the sine of 87. So y is approximately 8.492, and x is approximately, I'm sorry, yes, 5.74. Okay, and we'll say that's all in kilometers, right? Because that 10 was in kilometers, so we can assume these will be in kilometers too. Okay. So the boat is closer to which dock? Dock 2. Have I finished answering the question, though, by saying that? No, because the question is not just which dock is the boat closer to, it's also how much closer. So how can I figure that out? How can I figure out how much closer the boat is to dock 2 than it is to dock 1? What can we do? Yeah, sure. Yeah, exactly. Just subtract 8.492 minus the 5.744. Okay, so by 2.748 kilometers. The boat is closer to dock 2 by 2.748 kilometers. Questions on any of that? Okay. So the last one here, letter C, a dock worker spots a swimmer hanging onto a buoy that is 3 kilometers away from dock 2. The buoy has a bearing of north 18 degrees east from the dock. So let's see here if we can add that in. Dock 2, we're going to go north. Okay, so here's north. We want to go 18 degrees east of that. So if I'm going to have to kind of like drawing a north there, and we go 18 degrees east to the right of that. So the buoy is going to be more like that, and it's 3 kilometers away from dock 2. So along this line here, it's going to be 3 kilometers away, and then there's the buoy or the swimmer. now we want to know how far would the fishing boat have to travel to rescue that swimmer. So in other words, we want to go from the fishing boat to that buoy. Okay. Ugh, that's a pretty busy picture right there. So we want to know this distance. I don't know, I'll call this like Z maybe to change it up now. Z.
Thank you, sir.
Wonderful.
That's that.
What I found after 30-second search.
Okay. Sounds good.
So it might be helpful here. I'm going to maybe redraw this just because there's so much going on in this other picture we've got here. So you've got the boat again. We know its distance to dock 2 is 5.744. And we know the dock to the buoy is 3 kilometers. And we want to know this distance here, Z. We know that this angle here is 18 degrees. We also know, I guess, that this angle here is 58 degrees. And then, yeah, okay. Okay, so, whew. Cass?
You can find the angle, that, like, dock 2,
Like this little wedge right here?
yeah.
Okay, how can we figure that out, or how?
Subtract 50 and 90.
Yeah, so again, we have another right angle, just like Alyssa pointed out earlier. We also, and Cassie's exactly right here, we have a right angle, okay? So that 58, together with this angle, will make a 90-degree angle, because that's straight north, and that's straight, like, due west, I guess, from the dock there. And so 90 minus 58, oops, yields 32 degrees right here. Okay. And let's see, maybe I can, yeah, okay. And so then the total angle here, this total angle is 32 plus 18, so that'll be 40. So, you know, if I say like the full, I mean 50. Thank you. 50 degrees. Okay, really squeezing it in there. Okay. So now what, though? We can't use law of sines here, right? Because we have an angle, but not the opposite side. We have these two other sides, though, of our triangle. What could we use here? Caleb? Law of cosines, right. This is a side, angle, side situation here. Okay? So, our setup, right, now this is not in A and B and C here, right? This is kind of tricky because it's not A, B, C. We have, like, you know, Z's and stuff like that thrown in. But the opposite side, this side that we're trying to solve for, that is the side where you start with the Z squared, okay? So it's going to be the Z squared equals, and then we'll use the other two sides here. So the 5.744 squared plus the other side, 3 squared, minus 2 times the 5.744 times the 3, and then cosine of the 50-degree angle there. Okay? So there it is, a law of cosines. We would use. This one's nice because you can type that whole thing just in your calculator. so it's approximately, or z squared is approximately 19.841, and so the square root, and I get that z is approximately 4.454 kilometers. Okay. And so that's the distance to the buoy. Okay. Questions on any of that? Okay, so there'll be one of these in the homework. It won't be quite like this challenging, just because it kind of it goes from law of sines to a law of cosines. Okay, there'll be one in the homework though that will be a bearing problem, so you can at least get to practice like setting things up and stuff like that. Okay, but that's it. All right, so sorry, so long again.